switch from factoring quadratic equations to solving quadratic equations. There are 5 total ways, 5 possible ways to solve a quadratic equation. And the first one that we're going to use is called completing the square. There was a couple videos back where we factored perfect square trinomials. Actually, it was the last video. And what this is going to allow us to do is it's going to allow us to turn every quadratic into a perfect square. Now, you might wonder, what does it mean to solve? Well, what it means to solve a quadratic equation is that you're trying to find the value for x that will make the left side of the equation equal 0. When we were factoring, there was no equal 0 on the right side like there is now. This part to the right of that red bracket wasn't even included, and it just asked us to factor. Well, now what it's asking us to do is it's asking us to solve it. And solving it means finding the value for x that would make the whole equation true. Well, since the right side says that it needs to equal 0, we want to know the value for x that's going to allow us to make this equal to 0. One of the first methods that I teach is solving by factoring. But since we just finished with perfect square trinomials, I figured I would do the completing the square trinomial or completing the square method first rather than going into solving by factoring. So this first trinomial here is obviously not a perfect square because this 8 at the end, the 8 is what's causing it, what's stopping it. And 6 isn't a perfect square either, but we really want to be concerned with the number in front of x squared and the constant. Are both of those perfect squares? And it's not. So what we're going to do is kind of get that 8 out of the way, and we're going to move it over to the other side of the equation. And we're going to move it by doing the opposite. Now this is kind of unusual. You don't do this in many of the other methods for solving, other than when you are solving using square roots, which I believe is the last video of solving quadratics that I have in the order. It doesn't matter which order you do these in. You could look at any of the solving quadratic equations in any order and it wouldn't make a difference. Now notice I kind of left a gap here. We're going to fill in this gap. Well, that wasn't a very straight line. We're going to fill in this gap with a number that's going to cause the polynomial on the left to be a perfect square polynomial. So the way that I'm going to do that is I'm going to take half of the number in front of x, which happens to be a 6. I'm going to take half of it, and then I'm going to square it. Remember, it has to be a perfect square in this spot, so that's why I'm going to square it. Half of 6 is 3. 3 squared equals 9. So to make this a perfect square trinomial on the left, I'm going to turn it into a positive 9. Adding 9 to the left side of my equation, though, just made my equation unbalanced. The left side of the equation got heavier than the right. So to balance it back out again, whatever I did to the left, I have to do to the right. So I have to add a positive 9 to both sides. I have to add it to the left to make it a perfect square trinomial, and I add it to the right to even the equation back out. Now, why did I do this? Whoops. Sorry, wrong button. I did it to create a perfect square. And a perfect square is one of those things where it factors to the same exact polynomials. X times x, and 3 times 3 gives me 9. 3 plus 3 actually adds up to 6, so I know that we've got x plus 3 times x plus 3. One of the times I had deleted my 9 up here, so I had to write that back in. And negative 8 plus 9 over here on the right is a 1. Please keep in mind that as you learn new methods, there might have been an easier method for solving this quadratic equation, but if the directions tell you that you have to solve it by completing the square, you have to solve it by completing the square. Sometimes completing the square is the one that works the best. But I don't know, completing the square would probably be the method for solving that I would go to last. And like I said, there's going to be 5 different methods that we're going to learn. Now the next thing I would do, as I showed you in an earlier video, rather than writing this as x plus 3 times x plus 3, I'm going to write it as x plus 3 quantity squared. And my ultimate goal here is to find out what x equals. So I need to get x alone. If I want to get x alone, I can't have it in these two different places. If I write x plus 3 times x plus 3 as x plus 3 quantity squared, now I have just one x in one spot. Problem is, though, there's a squared on the outside of this parenthesis. Well, to get rid of squaring something, I have to do the square root. A square root undoes squaring. Now you might think, what is a square root? And I'll do this again in a later video. But for example, a square root of 1, square root of 1 is 1 since 1 squared equals 1. Square root of 4 is 2 since 2 squared equals 2. Square root of 9 is 3 since 3 squared equals 9. Square root of 16 equals 4 since 4 squared equals 16. One thing that we're going to have to remember, though, is that there are also there's two answers to this. Not only could it be a positive one, but it could also be a negative one. Isn't it true that negative 1 squared also gives me a positive 1? And negative 2 squared also gives me a positive 4. And negative 3 squared also gives me a positive 9. And negative 4 squared also gives me a positive 16. So when I take square roots of numbers, I have to remember that there are two possible answers. And for every quadratic equation, there should always be two possible answers. Okay, I'll leave these off to the side for a little bit and then I'll erase them when I go do my next problem. But I took the square root on the left-hand side to get rid of this exponent because taking the square root undoes squaring. But whatever I have to do on the left, remember I got to do on the right also. So x plus 3 will now be on the left, and the square root and the squared are gone because they cancel each other out. And on the right, up here, the square root of 1 can equal plus or minus 1. So I actually have two answers over here. I have a positive 1, I have a negative 1. You can write these as two separate equations if you want. I have x plus 3 equals 1, or x plus 3 equals negative 1. So if I solve these two simple equations, I will find the value for x that's going to cause the left-hand side of the equation above to equal 0. It might be negative 2, or it might be negative 4. Whoops. Let's clean that up a little bit. All right, so how do I know that that's right? Get this out of here. To know that that's right, what I want to do is test those numbers in my original problem. Does negative 2 squared plus 6 times negative 2 plus 8 equal 0? Remember, my original problem was x squared plus 6x plus 8 equals 0. Let's see if it really does. Negative 2 squared is 4. 6 times negative 2 is negative 12. And then the plus 8 at the end. 4 plus negative 12 is negative 8. Negative 8 plus 8, does that equal 0? Sure it does. So 0 equals 0. That helps me to know that x equals negative 2 does work. Now I would do the same thing with the negative 4. Negative 4 squared plus 6 times negative 4. And all I keep doing is I keep looking back to the places up here where there's an x, and I'm changing them to the number that I'm testing. Right now I'm testing to see that this answer that I got, the second answer that I got, I'm checking to see if it works. And then I got a plus 8 equals 0. Basically, I'm copying the original problem but changing the x's to the numbers that I think are my solutions. Negative 4 squared is a positive 16. 6 times negative 4 is negative 24. Plus 8, does that equal 0? 16 plus negative 24 is negative 8. Here I got negative 8 plus 8 again, and we know from the last problem that, yep, it works. So x equals negative 4 is my second solution. Give you a few seconds if you're still copying that down. This testing part over here on the right, that's completely optional. When you're first solving these, you may want to get into the habit of doing that testing just to make sure that your calculations are right. Okay, the next equation, I can tell it's possibly a perfect square, but in all perfect square trinomials, there was always a positive over here. There's not a positive over here in this problem. And by over here, sorry, I mean this part right there. In a perfect square trinomial, that perfect square number on the right will always be a positive number. It isn't this time around. So it's not a perfect square trinomial. So the first thing I need to do is get this out of the way because it's stopping us from having a perfect square. And I'm going to leave a gap here because I'm going to fill in this gap with a number that will be a perfect square or will create a perfect square. In order to find that, I erased it before, but you take half of your b value and square it. Well, you might be wondering what b is. I cover this really heavily in the quadratic formula video. But b is always the number that's in front of the x. So in this case, it happens to be a 4. Half of 4 is 2, and 2 squared is 4. So the number that's going to create a perfect square over here is a positive 4. And on this side, I got to add 4 also because I want to keep my equation balanced out. So now I want to know what are my two factors. They're going to be the same exact thing that when I multiply them together would give me x squared plus 4x plus 4. And you might have even factored this in some of your problems on your perfect square trinomial quiz. X times x, 2 times 2 is what gives me 4. 2 plus 2 does add up to 4. So I know my identical factors are x plus 2 times x plus 2. X plus 2 quantity squared equals 13. Now I want to take the square root of both sides. I do not know the square root of 13 off the top of my head. It's not a nice even number, a nice whole number. It's got a decimal. So I'm going to wait here and I'm going to go to my calculator in just a bit. Right now I'm getting x alone by subtracting 2. So I know I can find my answers by typing into the calculator negative 2 plus the square root of 13. And then I can get the other one by typing in negative 2 minus the square root of 13. And the reason I've got 2 is because when you take the square root of a number, you get two solutions, the positive solution and the negative solution. And again, I don't know if my calculator shows up in here. If it doesn't, you can stop the video now and I can show you how to do it on the yellow calculators at school. If it does show up, great. I've got 13 and I want to take the square root of that, and then I'm going to add negative 2 to that answer, which gives me about, and I'd have to type this into the Moodle. Whoops, my calculator disappears when I write. 1.61 if I were to round that. So over here, 1.61. When you type into the yellow calculators at school, you're going to kind of type this in a different order. So I got the square root of 13, which this time I have to make negative because of the subtraction symbol in the front, and that doesn't allow me to do that. So I might have to approach this differently. Negative 2, oh wait, 13 square root, make it negative. So they negate the square root of 13, and I'm going to minus 2 from that answer and get negative 5.61. A lot of times my students think that it's going to be the same thing, negative 5.61. But with a negative sign in front. A lot of students think, oh, I got 1.61 for this answer. This one's going to be negative 1.61. Obviously, you can see that's not true. So those are my two solutions. That's how I would have to type them into Moodle. 2 decimal places. I could not type in to Moodle 2 plus or minus the square root of 13. If I weren't doing Moodle, this is how I'd expect you to write your answers. But Moodle is going to be looking for 2 decimal places.